Welcome to the ISL8203 module presentation. The ISL8203 is actually a complete power supply in a package. The Intersil modules integrate all the main power components, such as the controller, the MOSFETs, and the inductor, all in one single package to provide a complete solution, effectively making it plug and play. You just use an input cap, an output cap, and set the output voltage, and you're done. Now this product is suited for point-of-load applications where you need a step-down voltage from either a 3.3 volt or a 5 volt input. The output range is 0.8 to 5 volts, so it gives you a wide, flexible range for powering devices such as microcontrollers or analog bias rails on the system where you need lower current. Since the device is limited to a 3 amp output, it's really ideal for those smaller currents. Now you'll notice there's two independent outputs, each capable of 3 amps, or they can be combined to have a single output rated at up to 6 amps. The key benefits of the ISL8203 is that it provides a very fast, simple design for customers. By integrating all of those power components, there's very few decisions on the component selection. All that's required is those bulk input and output capacitors, and they just set the output voltage to the desired level, and that's it. And with the new QFN-based packaging that's utilized for this product, it can deliver the full 6 amp output current even at high ambient temperatures such as 85 degrees C without the need for heat sinks or fans. So shown on this slide is a typical application circuit where you have two independent output voltages that are being regulated, each up to 3 amps. And as you can see, very few components are required to realize a design. Looking a little closer at the circuit, you can see there's quite a few other auxiliary pins available on the device. For instance, there's 2 enable pins and 2 power good pins, so each one corresponds to the different output channel. This feature allows you to enable the channels independently, or by feeding the power good signal into the other enable, you can effectively sequence the rails. The output voltage is just adjusted by using a resistor divider network, so you get a wide flexibility in setting the range. Since the ISL8203 is based on the current mode control methodology, the two outputs can actually be parallel together. So by connecting the two outputs instead of a dual 3 amp device, it's possible to realize a single output up to 6 amps. The ISL8203 utilizes a new packaging technology for our modules. It's actually based on the QFN, the standard IC package, except it's just a little bit larger to incorporate the inductor and the MOSFETs. If you look on the footprint on the board underneath, you can see it looks just like a regular QFN. There's no floating pads except for the ground right in the middle, and all the pins come out to the side. This makes it very easy to lay out on the board, to manufacture it, and it can also inspect the solder on every single pin.
Next, we'll discuss the availability of the ISL8203 evaluation board.
There is a demo board available for the 8203 module. It's available on the web and can be ordered. What you see on this board is 2 independent outputs can be configured, or you can always jumper them together if you wanted a single 6 amp output. There's very few components around it, just a few input caps and a few output caps, and those are small ceramic capacitors, so minimal footprint. One of the major advantages of this demo board is on the left, you will see the jumpers. You can actually set the 2 different output voltages just by moving the jumpers around, so this allows you to quickly customize a board without needing a soldering iron. So here's a couple of efficiency curves from the demo board running at ambient temperature with either a 3.3 or a 5 volt input. And as you can see, for both of these cases across different voltages, there's a fairly high efficiency, typically peaking at about 95%. And on this slide, you can see the efficiency for the device when it's run with the 2 outputs paralleled to provide the single 6 amp output. So on the earlier slides, we talked about some of the performance with the 8203, specifically around the packaging technology and the thermals. So here is a shot shown of the demo board running a full 6 amp output. So it's a 5 volt input, 2.5 volt output. So that's 15 watts output running at ambient temperature. You can see with the 2.5 watts power dissipation in the package, the device is only heated up about 40 degrees to 65.8 degrees Celsius. That really translates into a theta JA of 17 degrees C per watt, which is extremely low. So the advantage is you can run this device at max ambient temperature, 85 degrees C, full load, without the need for airflow, so no heat sinking is required for this product. Looking at a few more characteristics of the device, this is the output voltage ripple. Now, one of the major concerns on the modules is with the integrated inductor, typically a sacrifice that's made is high output voltage ripple. But with the 8203, we're able to use a larger inductor value to minimize the amount of output voltage ripple. So as you can see, with a 1 volt output, the device only has 8 millivolts peak to peak of ripple, which is less than 0.4%. So it's extremely low amount of ripple, so the device is suited for analog rails, including sensitive analogs such as PLLs and clocks. One of the other benefits of this device is with the current mode control scheme, the device has a very nicely controlled soft start. So you can see the output voltage starting up into a 1.5 volt output with a full 6 amp load. What you can see is the output voltage is monotonic, so it gradually increases in a controlled manner. There's no overshoot, and the inrush on the input current is controlled. There's no spikes, so you won't hit an overcurrent event during startup. The other benefit to make this a very robust module is the short circuit protection that's built into this product. This device uses peak current control, so therefore any overcurrent events, it will shut down immediately. Now the device will do a continuous restart, but as you can see in these plots, even with a short circuit condition sustained, the device will not sit there and have excessive input power, so it limits any opportunity for smoke or fire. The device will not burn up for prolonged shorts. So just one of the advantages of having a very robust, solid architecture integrated into these modules. The last two tests that we'll show for the demo board is EMI performance, both from a conducted and a radiated emissions. So this first slide here shows the conducted EMI. Now this is run using the demo board without any additional circuitry. So there's no chokes on the input or anything else that would modify the results. And as you can see, it's well below the Class A and the Class B limits. And this plot here shows the radiated EMI performance. Now when you look at the graph, at first it looks like it may exceed the Class B limits at the lower frequencies, but that's actually the peak scan data. For the limits, we only have to pass on the quasi-peak number, and if you look at the table below, you can see we pass with several dB of margin. So we're able to pass both the radiated and the conducted EMI limits for Class B. Thank you for listening to the 8203 module presentation.